In example 2, we want to verify that 2 cosecant x is equal to 1 over cosecant x plus cotangent x plus 1 over cosecant x minus cotangent x. When you're working to figure out or to verify, you don't necessarily always have to work with the left side. You could work with either side. Since the right side looks a little bit more complicated, we're going to work with that side, and we're going to use the idea of adding these two fractions together by getting common denominators. So let's set it up. We have our statement here. And then we'll do our rule. So first step, we're going to go ahead and get those common denominators. So if I look for my common denominators is going to be cosecant x plus cotangent x and cosecant x minus cotangent x. So I need to multiply this first fraction by cosecant x minus cotangent x over itself, leaving me with cosecant x minus cotangent x all over cosecant x minus cotangent x times cosecant x plus cotangent x. And this again is just the first fraction, so that's just this one right here, and we're going to add to that. Now we're going to multiply the other fraction, this one, by the conjugate or the plus. So we get cosecant x plus cotangent x over cosecant x minus cotangent x times cosecant x plus cotangent x. And then I'm going to scoot over a little bit for the rule. So there's my statement. My rules we'll put over here. So rule number 1 was just algebra. Now coming back to our next step, step number 2, I'm going to go ahead and I'm going to combine my fractions together. Since they have common denominators, I'm going to do some algebra stuff in my next step, which means I'm going to start by combining the numerators. I have a cosecant x plus another cosecant x, which will give me 2 cosecant x. And then I have a negative cotangent x and a positive cotangent x, which are going to cancel each other out. And then I'm left with my denominator, which is cosecant x minus cotangent x times cosecant x plus cotangent x. And all I did here, rule number 2, was algebra stuff again. Continuing on with step number 3, I'm going to go ahead and simplify that denominator. Notice that this is a difference of squares, so when we multiply it out, we get 2 cosecant x on the top, and the bottom becomes cosecant squared x minus cotangent squared x. So once again, my rule here, I'm just doing a bunch of algebra stuff and simplifying. I haven't used any identities yet. Then step number 4, I can use my Pythagorean identity. Notice I have 2 things that are squared, and these 2 actually go together. And cosecant squared x minus cotangent squared x, I'm going to show you that really quick. So if we have our Pythagorean identity, cotangent squared x plus 1 is equal to cosecant squared x. All I'm doing is subtracting over the cotangent squared, and I get 1. So for step 4, I could say 2 cosecant x over 1. And here I used my Pythagorean identity. So my rule for number 4 was Pythagorean. And then if I go to step 5, I can just simplify this down. 2 cosecant x divided by 1 is just 2 cosecant x. And that was just a simplification, or I could say that was just algebra. Next, I would like you to try this. So pause the video, see what you can do on your own, and then you can check it when you're ready. If you did try this correctly, again, we could have different steps. You might have something slightly different than I do, and again, that's okay, and I'd be happy to check what you have. The first thing that I did, I worked with the left-hand side, and I get common denominators. So cosine of alpha over 1 times 1 minus sine alpha over 1 plus sine alpha times 1 minus sine alpha, plus I have cosine of alpha times 1 plus sine alpha over 1 plus sine alpha times 1 minus sine alpha. And my rule here was just algebra. Then in number 2, I went ahead and I did all the algebra stuff where I combined the numerator. So what I did is I multiplied these out, and then I simplified the denominator. So I have cosine theta minus, or alpha, sorry, cosine alpha sine alpha, plus, then I distributed over here, cosine alpha plus cosine alpha sine alpha, and then I multiplied out the difference of squares on the denominator, which was 1 minus sine squared alpha. So this was algebra. Then number 3, I went ahead and I simplified the numerator. So I have a cosine theta, or sorry, cosine alpha and another cosine alpha. So that gives me 2 cosine alphas. And then I have a negative cosine alpha sine alpha and a positive cosine alpha sine alpha. Those two are going to cancel out. And then my denominator is still 1 minus sine squared alpha. And number 3 again was algebra. Then my step 4, I can use my Pythagorean identity. 1 minus sine squared is cosine squared. So I have 2 cosine alpha over cosine squared alpha. And that step number 4 was a Pythagorean identity. And I've kind of run out of room there, so I'm going to move everything over here to the other side and just set it up again. So here's my statement, here's my rule, and we're on to step number 5. So from there, I can cancel out one of the cosines, leaving me with 2 over cosine alpha. And that was just an algebra skill. And then finally, I can use my reciprocal identity. I can move the cosine up into a secant of alpha. And then this would be reciprocal. And then I'm running out of room, so that should say reciprocal right there. If you have questions, let me know.